Hello there, Mr. Chan here with Algebra 2, about to do a topic 5 topic review. Please grab your worksheet. We're starting on page 290. There are a lot of sections here, so hang in there. If you have any questions, please shout out and we'll pause the video and see what we can do to answer questions. We have some vocabulary to start out with. Let's get going here. Here we go. Number 2, in the expression the nth root of c, n is the index. That's what it is, the index. Number 3, in the expression the nth root of c, c is the radicand. That's the value inside the radical. The radicand. Number 4, radicals with the same index and the same radicand are like radicals. Number 5, a blank is a function defined by a radical expression. It's just a radical function. Number 6, a blank of a number c is x, such that x to the n equals c. In this case, it's the nth root. Number 7, a blank is a potential solution that must be rejected because it does not satisfy the original equation. That is extraneous solution. For this particular chapter, it's because we cannot take the square or fourth or sixth root of a negative number, usually, or some other situation where it doesn't equal to each other. Number 8, when all nth roots of perfect nth powers have been simplified and no radicals remain in the denominator, an expression is in reduced radical form. Number 9, a blank results from the application of one function to the output of another function. That's called a composite function. All right. Excuse me. Let's get started with 5-1. This particular section is called nth roots, radicals, and rational exponents. There's some vocabulary here involving all the parts of a radical. You can look through that on your own. There's a nice example here. Very cool. I'm going to do number 10 here, the start here. What is the value of each expression? Let me zoom in a little bit. We might have to use some space to the right, of course, in a moment. Let's do this. Yes, much better. All right, number 10. What is the value of each expression? Round to the nearest hundredth if necessary. We're looking for the fourth root of 16 squared. 16's breakdownable to 4 and 4, and each of those can be broken down to 2, 2, 2, 2. So 16 is definitely 2, 2, 2, 2. There's a grouping right there of 4, because that's what we're looking for, the fourth root. But we have how many of those grouping of 4s? We have 2 of them, okay? So hold on a second. That grouping of 4 2's comes out as a single 2, but because there's 2 of them, I'm going to square it. That comes out as well. We have 2 groups of 4 2's. 2 squared when it comes out, nothing else is left underneath. That's simply 4 as an answer. Ding, 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 ding. Number 11, we have a lot of things going on here. In this case, our index is 3. This is the cube root. We're looking for triples. Let's break down the base there. Now, there's a negative right there. We're going to ignore that for now and carry that over to the final answer. They're just trying to trick us, I think. 25 can be broken down. That is 5 and 5. Now, interestingly enough, we have 6 of those pair of fives. 6 times 2 is 12 fives. Think about that, right? So this is now the cube root of 5 to the 12th power, right? Now, we're looking for triples to come out. In fact, 12 is divisible by 3. In fact, 4 of them come out. That is your situation. And don't forget about the negative sign. That negative sign is kind of hanging out there. So 5 to the 4th power. Remember, there's 12 initially, fives, divided by 3 gives me an even 4. 5 to the 4th power is, dun, 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 negative 625 is the answer. Yay. Number 12, we're looking for cube roots. That's an odd root. So far, as you recall from this section, we do have to worry about any even roots. Right now it's an odd root for number 12, so I don't have to worry about that. In a moment though, number 13, it will be an even root. I do need to worry about any negative variables that might come out. Let's break down number 12 though. 12, the number 27 is 3 times 9. 9 is breakdownable to 3 times 3. So there's my triple, yay. X's, I have 12 X's. That can be divisible by the 3 on the outside. 12 divided by 3 is 4. Remember, just think about it. And I might have jumped the gun there with number 11, but think about it. It's x to the 4, x to the 4, x to the 4, because 4 plus 4 plus 4 is 12, right? There's 3 of them that come out. When they come out, they come out as a single x to the 4th power. Nothing's left underneath. Therefore, my final answer here is 3x to the 4th. Yay. That's it. Number 13, we're looking for an even power, okay? We want to make sure any variables we take out, if there is an odd number of variables, we have to make them positive with absolute value. We'll see what happens here. All right, break down the 16. That's just 4 times 4. Oh, that's just 2, 2, 2, 2. Interesting. Yay, there's a group of 4 there. A to the 24th is divisible by 4. B to the 8th is divisible by 4 groups. Therefore, there's nothing left underneath. So we're going to get a 2. A to the 24 divided by 4 is 6. B to the 8 divided by 4 is 2 power. Very nice. Now here's the weird thing about this answer. We don't have to worry about any negatives because a to the 6 will guarantee will be a positive answer. B to the 2nd power will guarantee will be a positive answer because any negatives brought to an even power will be positive. Number 14 is next. We have a simple problem to solve there. I'm going to go ahead and divide by 6 first. There's some room there. Okay. Then I'm going to scooch on over to here to finish it off. Number 14. 6 does goes into 750 evenly. It does. Let me do this in my head. 6 goes into 7 once. Carry the 1 twice. Carry the 3 5 times. Bam. Woo. Mental math hurts. Ooh, I got to get rid of that cube. The opposite of cube is cube root both sides. And lo and behold, 125 is breakdownable. 5 times 25. 25 goes to 5 as well. Oh, yay, there's my triple right there. Very nice. Y equals 5. That's it. Pretty easy. Number 15 is next. I'm going to go ahead and divide by 5 first. Yes, it does divide into the funny number right there, 1,280. When I do that, I will get, let's see, 2, carry the 2, 5, carry the 3, 6. Gives me z to the 4th power, yay. All right, you got to be careful here. The opposite of 4th power is a 4th root. It's an even power. When it comes to an equation, I have to introduce a plus or minus. With the situation. All right. 256 is breakdownable. It's 16 times 16, and that can be broken down further. That's 4, 4, 4, 4. Did you know that? That's crazy, huh? 256. And I'm going to stop there because there's my grouping of 4 right there. Unnecessary to go further. Bam. The fourth root of 256 is plus or minus 4. That equals the z. All right. Not too bad. You guys ready for the next section? Let's do it. Let's move on. Let me know if you have any questions, of course. 5-2. Properties of exponents and radicals. There's a nice little review of product property of radicals and quotient property of radicals. Here's a nice example playing around with those radicals there. Let's get started with number 18. Yeah, shall we? Let's do it. Number 18. I have a feeling I'm going to need some room at the top here. Yes, definitely. Now, both radicals there are square roots, so they can be combined together with number 18. So let's put that together into one radical. That's allowed. X to the 6 will be grouped with X to the 8th. This is kind of nice to line them up. Y to the 4th is nicely grouped with Y to the 6. Put that together even further. I get, add the exponents there. 6 plus 8 is 14. Y to the 4 plus 6 is 10. Yay! Remember, the index is a square root. When it comes to powers, what you do is break it into equal parts. 14 is divisible by 2, so is 10. And nothing's left underneath the radical. So that means this is X to the 7th and Y to the 5th. And that is your simplified radical right there for number 18. Very nice. Number 19, let's do that one up here. I'm going to go ahead and reduce the 3 and the 243 and the m to the 4th here to save some space. So 3 goes into 243 81 times. That m right there will cancel with one of those m's, gives me that right there. So let me write the result up here. This is the cube root of 81 m to the 3rd. 81's breakdownable, 9 and 9. And those 9s are 3, 3. Uh-oh, this is interesting. I need 3 numbers. I have an extra one of them, don't I? So that triple, because of the index, comes out. The m's I have enough, so that's MMM, so that's cool. That comes out. But I have a leftover 3 on the inside. So I have an unusual answer here. This is 3m times the cube root of 3 as my final answer. All right. Number 20 is next. We have cube roots across the board there. I'm going to group them all together. You can do that. That's according to one of the properties, the product property of radicals. That's allowed to put them all together. So I have the numbers first, 5 times 25. And then I have the x's. I'm going to group all those together too. Like that. Okay? And I'm going to continue the rest up here. I've ran out of room there. 5 times 25 is 125. And if you count all the x's there, 4 plus 2 plus 3 is 9. Very interesting. We know that 125 is breakdownable. 5, 5, 5. There's my triple. And x to the 9th, you can group it into x to the 3rd power. Very nice. This is an odd root. I don't have to worry about any pluses or minuses. That is your final answer for number 20. Number 21, I'm going to go ahead and reduce that as best I could first. 2 goes into 98 49 times. 8 to the 4th cancels with 4 of those up there, leaving with 6 of them. That leaves me with, whoops. What is that? The square root of 49, x to the 6, yay. That is nice. Square root of 49 is 7, square root of x to the 6, group of them to x to the 3rd, x to the 3rd, there it is. Now be careful here. This is an even root. Look at the number of x's that come out. Did I put x there? I meant to put a's. Oops. Sorry about that. a to the 6, a to the third. Okay, a to the third is an odd number of a's. I can't guarantee that all of them could not be negative, so I have to guarantee it to be positive by putting some absolute value. And there's my answer for number 21. Yay. All right, that takes care of just simplifying radicals. Number 22 through 25 looks like a bunch of multiplication. I don't have a lot of room here. I will be doing FOIL for the first 3 of those. And the last one looks like a simple distributive property. So I'll be cranking through those here. Let's do 22 first. I'm going to do FOIL. First terms, 22. Root n times root n is regular n. Yay. Next are outer terms. Root n times 3 root 7. Now be careful. You want to multiply numbers on the outside of the radical with each other and numbers or variables on the inside with each other. So here, with the outer product, I'll get plus 3 root 7n on the inside, okay? Inner terms are next. Minus root 7 times root n is minus root 7n. Interesting. And then last terms we have a negative times a positive is a negative 3 root 7 times root 7. Interesting. That's just plain old 7. Right? Root 7 times root 7 is regular 7. Clean up that mess right there. The middle 2 can be combined together. Look at that. 3 of those root 7n's and negative 1 of those root 7n's will give me 2 of those root 7n's. And there's your answer for number 22. And minus 3 times 7 is 21 on the end. And there's your answer. Yay. Number 24. Sorry, 23. Excuse me. All right. 23. Let's FOIL this. A lot of random expressions here you got to worry about. First term is 9x times 9x. 81x squared. Nice. Outer terms, 9x times root 2. Those are separate. So that's plus 9x root 2. Oh, inner terms, same. 9x root 2 as well. And last terms, what do we got? Root 2 times root 2 is regular 2. The middle, the inner and the outer terms can be combined together. 9 of those plus 9 of those is 18 of those. And that's it. It's a funny answer. 24 is next. Woohoo! Going along pretty fast. Feel free to have me pause and answer questions anytime. Here we go. First terms. Be careful here. 5 root 3 times 5 root 3 is 25 times regular 3. Right? 5 is 25. And root 3 is regular 3. Outer terms are next. We'll deal with that 25 times 3 in a minute. We have 5 root 3 times negative 6. So that's going to be minus 30 root 3. Okay. Inner terms are next. 6 times 5 root 3. That's going to be plus. Oh, interesting. 30 root 3. In fact, I'm recognizing that this number 24 are conjugates. Right? With a plus and a minus of the same binomial there. When you FOIL conjugates, the O and the I will disappear like you can see right there. Last terms, 6 times negative 6 is negative 36. Like I said earlier, the inner and the outer terms cancel. And we have 25 times 3 is 75. 75 minus 36 is simply, what is that? 39? Yay. Any questions? Not too bad. So 25 is 39. All right. Okay. Next problem. What number are we up to? 25. All right. Oh, this is just the distributive property, no big deal. Some weird roots here. Root 4 times 6 cube root of, not root 4, cube root of 4 times 6 cube root of 2. The 6 is on the outside, so leave that alone. And the root 4 and the cube root of 4 and the cube root of 2 is on the inside. Interesting, right there. So that's 4 times 2 on the inside. Then let's do the other distributed part. That's going to be minus 1 cube root of 4. Okay, fine. That looks kind of funny. 4 times 2 on the inside of the first radical is 8. Ooh, 8's breakdownable. That's 2, 2, 2. Nice. So that comes out as a regular 2. And final answer is 12 minus cube root of 4. Nothing else you can do with that particular number. That's your answer. Strange looking, huh? All right. How we doing? All right. Oh my goodness. We got some rationalizing the denominator to take care of. We can't have radicals in the denominator. We need to rationalize. Let's write that down. Rationalize the denominator. Now, the key with most of these, 26, 27, 28, is to multiply by the conjugate. Conjugates are A plus root B and A minus root B. That's one way of looking at them, okay? So all these binomials, you just have to multiply by the conjugate, 26, 27, 28, and that will help you with getting rid of the radicals in the denominator. 29 is a little easier because it's a single monomial. You don't have to worry about that. Here we go, number 26. I have a feeling I might run out of room, so I'm going to go ahead and scooch on over here to here. 26, we have 6 over 1 plus root 2. Parenthesize those polynomials. Great. I'm going to multiply the numerator and the denominator by the conjugate. And that, in this case, is 1 minus root 2. Okay, the rest is just cleaning this up. Just doing the math. Let's do the numerator first. 6 times that binomial there is 6 minus 6 root 2. The denominator, whenever you multiply by the conjugate, the inner and the outer terms will always disappear. You don't have to write them at all. So when you rationalize the denominator by multiplying by the conjugate, the O and the I will disappear. You don't have to worry about that inner outer product. So much easier, okay? So let me show you up here. 1 times 1 is 1. And then the last terms is positive root 2 times negative root 2 is negative 2, right? Root 2 times root 2 is regular 2. Great. 1 minus 2 in the denominator is negative 1. And the top is like that. I mean, you can leave the answer like that, or simply just apply the negative to the numerator, and your final answer will be negative 6 plus 6 root 2. That's a little nicer looking, and that's my answer right there, okay? Yay. 27's next. Let's do that one over here to the far right. Here we go. 5 over 2 minus root 5. Again, we're going to multiply top and bottom by the conjugate. In this case, it's going to be 2 plus root 5. You do this a few times, and you kind of get used to the conjugate thing. Let's distribute the numerator. 5 times 2 is 10, plus 5 root 5. Remember, radicals on the inside, numbers on the outside, leave them alone separately. Denominator is kind of interesting. Foil, we're going to do the F and the L. 2 times 2 is 4. And then the last terms are negative. Root 5 times root 5 is regular. Oh, interesting. We have another negative 1. 4 minus 5 is negative 1 on the bottom. And then 10 plus 5 root 5 in the numerator. This, of course, when you apply the negative 1, becomes negative 10 minus 5 root 5. Yay. Woo. Ready for number 28? Any questions on 27? Okay. 28. Oh, this is a little more complicated. Still have a binomial. And our conjugate in the denominator, of course, is 3 plus 3 root 6. Tops and bottoms. Okay, let's do I'll do the denominator first this time. What do we got? Whoops. Oh boy. OCD kicking in. 3 times 3 is 9. And the last terms, ew. 3, negative 3 is negative 9. Root 6 times root 6 is just 6, right? So there's that. So that'll be, yeah, we'll worry about that in a second. It's 54, right? It's 54. 9 minus 54 is negative 45. Wow, interesting. Okay, we'll come back to that in a second. Numerator, foil. We've got to do regular foil here. 4 times 3 is 12. 4 times 3 root 6 is 12, 6. Inner terms, 3 root 6. And last terms, root 6 times 3 root 6 is, let me double check this. Yep. 3 times 6, interesting. The inner and the outer terms do add up. 12 of those 6s and root 6, and then 3 of those 15. 3 times 16 on the end is 18. Oh, 12 plus 18 on the far ends are 30. Interesting. The inner two terms are 15 root 6. Whoa, 30, 15, 45. Those are divisible. Looks like they could all be divided by 15. Very cool. So that's all divisible. Crazy. So 30 divided by 15 is 2. 15 divided by 15 is 1, root 6. And negative 45 divided by 15 is negative 3. There's your answer. I mean, there's a couple ways to represent that, of course. 29, let's get going. Wow, we're still on the second section. There are 6 sections, oh my gosh. This is crazy. All right, number 29 is a little easier. We'll just need to multiply by the radical. Top, in this case, top and bottom, just root x like that, just like that. No conjugates here. Root x times root x in the denominator is just simply x. In the numerator is negative 9x root x. And luckily, those x's go away, leaving with an answer of negative 9 root x. Yay, there it is. Whew. This is definitely the longest section, 5-2. All right, let's move on to 5-3. Here we go. Oh, yay, we're doing some graphing here. Break out your graphing calculator, Desmos, blah, blah, blah. There's a typo on 5-3 I noticed when I looked through the notes. That little a right there is wrong. That should be a big A, okay? So write this as a nth root x minus h plus k. We all know what these do. I will remind you, of course, a is a vertical stretch, shrink, or reflection. Okay. H, of course, is on the inside. This is a horizontal shift, left to right. And k, of course, is up and down. It's on the outside of the function. This is shift, up or down. Okay. Yay. Couple of paragraphs. The one shown here, this radical function, is the square root of x. Definitely. That is your parent graph there, okay? Square root. I do want to point out the cube root function is also in play here. And before I do that, let me remind you of 0, 0, 1, 1, 4, 2 are my 3 major points for there. And HK, of course, is that starting point right there. Bam. There's your HK. Right now it's normally at 0, 0. And the other parent graph I would like to point out that will help us here is the cube root function. And I'm going to squeeze it right here. Let's do that really quick. This guy, cube root function, looks like this. Let's do that again. Okay, that's much better. This is the cube root function. Okay. And here, the HK is definitely right there, smack dab in the middle. Yay. All right, let's try some of these problems. These are all graphed. There's not a lot of room here necessarily to show this. I'm going to talk you through it compared to the parent graph. Number 32, let's just go through all these and talk about H, K, and A values. Okay, that -1 is definitely K. That means this is going down. Okay. I'll come back and show you the graphs in a minute. Okay, nothing else is going. That's a square root function. And number 33, we'll talk about the domain and range as well for all these. Oh, that too is also K. This is the cube root function. This is going up, interestingly enough. Number 34 is, oh, we've got two things going on. We have an A value of 1/2. Which means this is a vertical shrink, right? It's a vertical shrink. That one on the inside is H, backwards. This is going to the left. A little crowded here. We'll definitely put a lot more information to the right in a moment. Number 35, let's take a look at that. We got not only an A value, which is +2, which does definitely stretch it. Vertical stretch. But that -1 is a K value. This is down, right? It's negative. Whew, a lot of little things going on here. Number 36. That is a cube root function that has -3 on the inside. Is +3 as an H value. This is going to the right. Okay, great. Number 37 is a square root function. We have two values. H is on the inside. -4, this is going to the left. Negative go to the left, it's backwards. That -2 is K. This is going down. All right, very nice. So we have 6 functions here, both radicals, I'm sorry, both square roots and cube roots. I'm going to go ahead and show you 32. Here we go. Yay. There it is. Very nice. So in this case, it's definitely going down compared to the regular square root function. As you can see, it goes down 1 unit down, okay? Now, it's going to ask for the domain and range. Domain is based off of HK right there. So the HK is 0, -1, okay? Remember that. We'll carry that over to the other side in a moment. And they also ask whether this function is increasing or decreasing. If you look at the red graph here, it's increasing from left to right. Yay, that was number 32. Number 33, oh yay, this is kind of cool. It's the cube root function. The cube root function in this case has been shifted to 0, 2. It's shifted up to, like I mentioned earlier. Domain and range is easy. It's just all real numbers for that particular graph. No matter how much you stretch it, shrink it, or reflect it, it's always going to be all real numbers. And it's definitely increasing from left to right. All right, that's number 33. 34 looks like this. It is a square root function. It's been shrunk. Look at that. It's been shrunk in half vertically. And the domain's been shifted to -1 right there. Yeah, you'll see that? To -1. And it's going to the right. So the domain is x is greater than or equal to -1. The range is y is greater than or equal to 0. Write that in a moment. And that is definitely increasing. All these are increasing. Not that exciting. I wish they had a reflection. None of these have a -a. None of these 6 problems have a -a. I'm sad. Number 35. Oh, this is kind of cool. It's been stretched by a factor of 2. Look at that. It's been shifted down 1. Domain and range is all real numbers, and it's definitely increasing still. Number 36, been shifted to the right 3 units. Definitely this cube root function. Domain range is all real numbers, and it's also still increasing from left to right. And finally, number 37, it's a square root function that's been shifted left 4, 2 down. And it's going to the right. It's increasing. And the domain is x is greater than or equal to -4, the h value. And the range is y is greater than or equal to -2, the y value. All right. Let's translate that all to our notes here. There's a lot going on here. So 32, domain was x is greater than or equal to 0, range definitely y is greater than or equal to -1. The graph, there's really not a lot of room here, but if you really want to see what it looks like, it was like this. I'll do it. Why not? What is that? Down 1. Okay, so its graph looks like this. Yay. And it's definitely increasing. Ah, very nice. 33. The domain for number 33 is all real numbers, and the range is also all real numbers. It's also increasing. Its graph looks like this. It was shifted up too, so it looks something like right here. That. Okay. Very nice. 33 is next. I'm sorry, 34. The domain for 34 is x is greater than or equal to -1. That's the h value. The range is y is greater than or equal to 0. It's also increasing. Not that exciting. And the graph of this function looks like this. It's shrunk, so it's a little skinnier, right? And it's been shifted to the left one. There we go. Okay, 35. The domain is all real numbers again. Yay, it's the cube root function. The range is all real numbers. It's also increasing. And this particular graph, where did it go? It's been stretched and it's been moved downwards. Fine. There we go. Yay. 36 is next. Domain is, oh, another cubic root function. This is all real numbers. And the range is all real numbers. And it's increasing as well. Ooh, not as bad as the last section. Last section was pretty much horrendous there. Number 36 is definitely shifting to the right. 1, 2, 3. So it looks like this. Okay, nice. 37. Finally. Ooh. Domain is x is greater than or equal to -4. Because that's your h value. Range is y is greater than or equal to -2. It's also increasing. Oh, wow. Left 4, down 2. All right. Left 4, down 2. 2, 3, 4, down 2. There it is. There's my function. Yay. All right. I looked at number 38, and I think I need to talk about it. 38 is not in a form that is easily recognizable. So what I'm going to do is manipulate the 8 that's inside. 8, fortunately, can divide into 24 as well. So watch what I do. I'm going to factor out an 8 from that binomial inside there. I get x minus 3. And thank goodness we're looking for the cube root. The cube root of 8 is 2, 2, 2, right? So that's just regular 2. That comes out. So, whew, not that bad. There's my a value. That's a vertical stretch. My h value, of course, is positive 3. This is going to the right. And my k value is positive 1. This is going up. So this is a cube root function that gets stretched by 2, shifted to the right 3, and 1 up. Okay? All right. I think we're ready for the next section, 5-4. Here we go. Yeah, these reviews are long, I know. I guess you can come back to it later if you want to, just put it on hold. Oh, solving radicals. Oh my goodness. So the key to solving radical equations is to isolate the radical and then solve for x, or the variable. And then anytime you do this, you also want to check your solutions for extraneous answers. Keep that in mind. There's a nice example here that you can review on your own. I'm going to go and jump to number 40 and just get going here. There's a lot going on here. Here we go. Number 40. Solve and check your answers. I'm going to go ahead and save a little time and add 2 to both sides there. A little space there, and then continue the rest up here. Wish me luck. Here we go. So we have the cube root of x equals 9. Ooh, get rid of the cube root. That's the cube both sides. So when I do that, I'm left with an x equals 9 to the third is 9 times 9 times 9 is 729. That's a scary number there. I know. I didn't know that. I punched it into the calculator earlier. I'm not that good. Woo. 41. I'm going to go ahead and square both sides to save a little time. So that gives me for 41 right here. Let's do that. 2x equals 144. Divide by 2? No way. Yay. This is not too bad. X equals 72. Yay. Not too bad, not too bad, not too bad. How about 42? Let's crank that out. I feel I'm going to run out of room here soon. 42, let's put it all over here. I'm going to go ahead and subtract 5 to both sides to save some room there. That gives me square root of 25 plus x equals to 4. Square both sides. Nice. That leaves me with 25 plus x equals 4 squared is 16. Oh, yay. Subtract 25 to both sides. Not too bad. These are actually a lot easier than the actual lesson that we learned a while back. And there's your answer. Check it though. -9 inside is 25 minus 9 is 16. Yeah, that works. Should always check, right? Should always check the answer. There's your answer. All right, 43 is next. I wonder if I need more room here. Nah, I can squeeze that in. 43. Yeah, this section and the last section is definitely faster than 5-2. That was a longer in this section. I'm going to go and subtract 13 to both sides first to save some time and room there. That leaves me with a -4th root of x equals to -3. Hey, let's get rid of that -1. Why not? Ooh, opposite of 4th root is 4th power both sides. Interesting. X equals 3 to the 4th power. 3, 3, 3, 3 is 81. Not too bad. Okay. Woo. 44 is next. Let's do that one. All right. I'm going to go ahead and subtract 1 to both sides. Ooh, this is going to be a lot of work here. Root 5x plus 1 equals to x minus 1. I need to square both sides. Now that I have isolated the radical, I need to expand and FOIL x minus 1 eventually. Not looking forward to that. Boo. So the left side, though, I'm left with a 5x plus 1. The right side, I have x minus 1 times itself. I need to FOIL that, right? Takes a little time. All these skills from Algebra 1 come into play. X squared minus x plus 1. I'm going to go ahead and subtract 5x and 1 to the other side. Ooh, that's interesting. 0 equals to x squared minus, let's see, 1, 2, 7x. Oh, the 1's go away. This is not your typical quadratic. It's a binomial that can factor out an x. And then using the zero product property, I can solve those individually. Like that. Do they both work? Let's try it. Let's plug 0 back into the original problem. 0, oh no, 5 times 0 is 0, plus 1 is 1, square root of 1 is 1, 1 plus 1 is 2, not 0. 0 is extraneous. Womp, womp, womp. How about 7? 5 times 7? 35 plus 1 is 36. Square root of 36 is 6. 6 plus 1 is 7. Yay, ding, 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 ding. 7 is a solution. All right, last one. Yep, last one on this section. Let's do it. Number 45. I'm going to go ahead and add x to both sides to save some room here. Oops, I'm sloppy. Okay, that gives me with the root 6x minus 20 equals to x minus 6 on the other side. I'm going to go ahead and square both. I'm being super lazy here to do that. Okay, we can do that. Square, square root go away on the left. On the right, I got to expand and FOIL. Those are a pain, aren't they? Major pain. All right. So 6x minus 20 equals to FOIL that, x squared minus 6x minus 6x plus 36. I'm going to move the 6x minus 20 to the other side. Might as well. And let's see what we get. Oh my gosh, 56, that's a scary number. Think of all the possible ways of getting 56. When added together, it'll give me negative 18. Right? Oh, this is a lot of work there. And they both have to be negative, right? Negative 1, negative 56, negative 2, negative 28, negative 3, nope, negative 4. Negative 14. Oh, there it is. Woohoo. Luck, 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 luck. That works. Split them up and solve. Oh boy. Let's check this out from the original problem. Here we go. 6 times 4 is 24. Minus 20 is 4. Square root of 4 is 2. 2 minus 4 is not negative 6. That's extraneous. Let's try 14. 14 times 6 is 64. 64, oh, 84, my bad. 84 minus 20 is 64. 64 square root is 8. 8 minus 14 is negative 6. Wow, crazy. Ready for the last page? Let's do it. You should go pretty fast. All right, 5.5 and 5.6 will go fast, I promise. They're just functions. The main 4, add, subtract, multiply, and divide, of course, you know. Whenever you add and subtract, you definitely want to combine like terms. When you multiply, you want to know your properties of exponents, of course. But the new one that's kind of fascinating is composition, right? And that, of course, you mentioned is fog with that little circle there. That's a symbol right there. And that's your composition. You're putting a function within another function's variable x. There's a nice example right here on the bottom there. You can look through that yourself. Notice I do use the analogy of a turkey and stuffing. In this case, when you say F, the first letter, that's the turkey. G is the stuffing. All right. Let's take a look at number 48. We're just adding. Oh, that's all we're doing. Not that exciting. Okay, we'll do it. and f and g. Here are the two functions, f and g. We're going to do that for number 48 right now. 48. F plus g is negative x plus 6 plus 5x. Combine like terms, of course. And that gets us 4x plus 6. That's it. Nothing too exciting. 49 is x. We're subtracting f and g. Here's f again. This time we're going to subtract g. Ooh, watch out for those signs there. Negative 1x and negative 5x is negative 6x. And there's your answer for number 49. Woo! 50, 51. It's interesting. They don't ask us to use letters. They ask us to plug in a number inside f and that answer inside g. Okay, so that's the progression. F of 2 means plug in 2 for f and then take that answer and plug it into g last. Okay, that's the progression, inner to the outer side. So here's number 50. Let's do f of 2 first. Right, we're just doing the inside right there. Okay, f of 2, take the function f of x and replace x with 2. That's all we're doing. So in this case, this equals a negative 2 plus 6. That equals positive 4. Yay. That answer put into g. Makes sense? So g of f of 2, the answer we just got 4 goes into here. Okay? So we're looking for g of 4 now. That's what that means. G is 5x. You put the 4 in there. 5 times 4 is 20. So number 50, the answer is 20. Okay? Yay. 51 is next. So these are pretty straightforward. They're pretty easy, actually. Not too bad. We're looking at f of g of negative 1. We want to put negative 1 in for g first. Do that. Plug it into g. So negative 1 goes into there. 5 times negative 1 is negative 5. Yay. Now you take that negative 5 and plug it into f. We're putting it to here. Okay, we're substituting, basically. F of negative 5, let's plug negative 5 into f. F is negative x plus 6. You're putting a negative 5 right there, okay? Makes sense? Negative 5 is positive 5. 5 plus 6 is 11. Very good. Wow, that was pretty fast. You guys ready for the last section? All right. So we've done radicals, we've done cube roots, square roots, we've done graphing them. We're now going to find actual inverse relations with the next section, 5-6. The rule when finding inverses is to swap x and y to find the inverse relation and isolate y. When you come up with the inverse function, the notation is f to the negative 1 of x. Now be careful. F of negative 1 of x doesn't mean to put it, to reciprocate it, okay? That is not that. That is not equal to that. Please note that, okay? All right. Any questions? Just note that, okay? All right. Let's try to go ahead and swap x and y and solve for x. Let's start with number 54. Here we go. All those f of x's are the letter y's. I'm not going to do 58. That's no big deal. You can do it on your own. Here we go. Step 1, swap x and y. Let's see, find some room here. So y becomes x and x becomes y. And now you just have to isolate y and solve it. That's step 2. All right, I got to get rid of the -4, the square, the 3. I got to get rid of adds and subtracts first. Let's subtract 3 to both sides. It's going to look ugly. You don't have to make it look pretty, though. Next step, multiplication versus powers. Order of operations backwards. You got to get rid of multiplication division next. Subtract divide by -4. Nice. Finally, get rid of that square. Square root both sides. Don't forget about the plus minus. So pi y squared. Final answer is an ugly answer, but this is it. Don't make it pretty. There's your answer. You're just rearranging the furniture for 54. Yay. Let's do 55. Oops. Swap x and y. Let's do that. X equals to the square root of y minus 4. Yay. We need to solve for y. That's buried inside the radical. It's also covering -4, so I can't get rid of that -4 yet until I square both sides. Very nice. Square root and square go away on the right. And add 4 to both sides. Oh, by the way, I neglected to write f to the -1 of x. That's what I meant to do. Sorry about that. That's what we need to do there. Any questions about number 55? All right, 56 is next. 2 more to go. I can smell it. Trying to get it under an hour here, folks. We can do it. 56. Swap x and y. These seem a little easier, progressively speaking. Let's move everything away from y. Subtract 5 to both sides. Wow, this is like the easiest one yet. And divide by 9. No way. Yeah. There it is. That's the inverse. Whew. Got 2 minutes to do the last one. Is that possible? 57 is next. Swap x and y. Ooh, move the 1 to the other side. I'm undoing operations, as you know. Square both sides? Ouch. I'm going to leave that. I'm not going to expand and FOIL that. No, leave it alone. Who cares? And finally, subtract 7 to both sides. You're kidding me. That's it? That's it. Oops, very messy. Yay. Well, thank you very much. We got it under an hour. I appreciate it. Thank you very much. Have a good day. See you next time. Bye-bye.